but now we're seeing 0.009 and we still have the million ohm setting. What would that be? Well, that would be 9,000. It's the way that we would read that. Hey folks, how's it going? For those of you that are new to the channel, my name is Luke, and I'm going to be going over every single test setting on your commercial electric DMM-8301 multimeter. So if you're a beginner, intermediate, you're not understanding one of the tests, what a symbol means, exactly how it all works, we're gonna go ahead and do a thorough investigation into every test setting for you. And then I'll also give you my personal thoughts in case you're looking for somewhat of a review video. I will say I'm pretty excited because it's been a little over a year since I had my first commercial electric on the channel, and I'm loving the upgrade. I'm really stoked with what they did with the color scheme and the layout of the dial and pricing. I think I paid like 36 or 38 bucks out the door for this older model. And then I paid like 29 bucks for this one. So not a bad deal. I think the functions are very, very similar, but we're still gonna run through every single one for you so you know what to expect while you're testing. So why don't you go ahead and grab a snack, have a seat, sit down, enjoy the video. If you found this video helpful, go ahead and give me a thumbs up. And if not, give me that thumbs down. Questions, comments, and concerns down in the comments section. Let me know. I like to try to get back to everybody. Let's hop into it. All right, I'm really excited for this commercial electric meter and the updates that they've done to it. Not a sponsor of the channel, but I mean, look at it. I don't know how well it came out in the first part of the video, but just look at the difference. I mean, it's not even the same ball game, right? Like, this thing is hideous. And I've actually enjoyed this thing. I've had it in a lot of different videos, but the color scheme is just awful. We're gonna go over a few things. The first is, what is true RMS and what does that have to do with our meter? Well, RMS is a unit of measurement that we can utilize for AC voltage and AC current. Now, this meter is only rated for measuring AC voltage and not current, but we can think about when we have AC voltage, it's alternating between plus and minus, okay? It's going back and forth through time. And so when you would measure something like that, if you try to take a snapshot of a measurement of something through time, where you take that measurement, depending on in what point in time you take that measurement, the voltage is gonna read different because it's going up and down. There's the peak voltage, and then there's in the middle, then the negative voltage, right? So what they do with RMS is the root mean squared value. And it's essentially the DC equivalent of that voltage or current so that they can output just one number for you. It can say 120 volts AC instead of going back and forth super quick and spitting out a whole bunch of different numbers, right? Because that's really confusing and inconsistent and nobody can keep track of that. So it spits out just the one number for you. And so that's true RMS. Not every meter is true RMS, so that is a nice feature. We'll go over the buttons really quickly. There's gonna be a selection switch. So for things that you can see, like this part is highlighted in green. Get a pointer here. This little part's highlighted in green. So it's gonna default to this little speaker guy you can see up here. And then if we want to get to the green guy, hit the selection switch, and boom, it switches it over to the diode setting. And then this hold button has two functions. The first is gonna be able to hold a measurement for you. So let's go ahead and go to AC voltage. Let's watch that glare for you. So let's say there's my measurement. I can press the hold button. I can take my leads off, and now it'll keep it there for me in case I want to write it down or show it to mom and dad so they can be so proud that I measured the voltage for the light bulb. Really good stuff. And then something that I did not see, which I'm very excited about, is it has LED indicators to show you where to plug your leads in. Now, this is not proprietary to commercial electric. I've seen it on a bunch of different meters. Very cool, but that's to help you understand when you're supposed to have your leads in which ports. So it's saying for this setting, I'm gonna have a lead, my red lead in here, my black lead in here. Now, the only time that you're gonna need to switch your red lead from here to here is if you're measuring the 10 amps, and then you notice that it switches over to here. Don't worry, we're gonna go through all the settings, so if that seems a little overwhelming, I'm totally with you. We're gonna go step by step, but it is a nice little function in case you were curious about what those LED indicators were for above the ports, is to help remind you where your leads are supposed to be plugged into the meter. That being said, this is a manual ranging multimeter. You're gonna notice that compared to other meters, there's a lot of different numbers on here. What do they mean? How do we use them? So we can see that when they designed this, they broke it up into chunks. So we can see that this is volts, that squiggly line is for AC, it's supposed to be a sine wave, or represents one like we were talking about earlier for RMS. Volts AC. And when you see these numbers, I want you to think up to. So this says, if I'm selected here, I can measure up to 200 volts AC. If I put it here, I can measure up to 600 volts AC. Now, if I'm measuring something that's less than 200 volts, I can still use either setting. It's gonna be about clarity, and we'll get to that in a moment. Something that they've done is they broke it up into sections for us. So this is our volts AC section. Then this is gonna be continuity and diode. This will be resistance, current DC, our battery, and then volts DC, the way that they've broken it up. We have our biggest number to our smallest number. And I like that they did that in order, unlike the Klein that I looked at the other day and it didn't. When we're making measurements with a manually selecting meter, I like to start big and work my way small to get an idea of what I'm trying to measure. And I'll give you an example of that. And because it's manually selecting or manual ranging, we're gonna be doing it for all the different test settings to give you multiple examples to really help it soak in. We're gonna start with the volts AC, and then we're just gonna work clockwise through that wheel and give you every example that I can. I want to take a voltage AC measurement. I do not know how much voltage AC I'm about to measure. It could be 240, 120. Maybe there's a fault with it. Maybe it's only 3 volts is there. Maybe there's nothing. What setting do I put my meter to? Well, I can start at the biggest number, which is my volts AC 600 volts, and I can simply take a measurement. Helps if my load is on. Okay, and I'm showing 113 to 114 volts. That's great. My 113 volts, let's do the hold button. Let's turn off this light bulb. My 113 volts is less than this 200. And I know that for this 200, I can measure up to 200 volts. So I can actually move my selector switch down. I can take that measurement, and now I can get more detail. Okay, and now I have to the tenths. I have a decimal place and I have to the tenths of that value. Why is that handy, and why does it work like that? Well, think about when we're starting big and working small. When we have a microscope and we want to look at something, we have the microscope put way out here. And what we're trying to look at is down here, and it's really fuzzy. And so we start up here and then we work our way in until we can see the picture in a lot of detail and a lot of clarity. It's the same kind of idea with a meter. We start with that 600, it's kind of way up here. We can see something's going on. And then as we zoom into that 200, oh, now we can get more clarity, more detail, more resolution in our measurement, right? That's volts AC. Let's move on. We're gonna, do that more and more with the resistance, the current, and the DC voltage. For continuity and diodes, what's that useful for and how can we utilize that? So it's gonna default to continuity. That's that little speaker setting right there. And all that means is that there's some kind of flow, right? Some kind of flow through a conductor. the wire isn't cut in half. Doesn't mean that the wire is great or perfect. It just means that there's some kind of flow. Another way that you can use it is to sort out which wire goes where. You take a look for this. Okay, that wire doesn't go to that one, but it does go to that one. What about this guy? Nothing there. Okay, so that can help us kind of sort it out, and it makes a tone because when we're working with multiple wires, we want to keep our eyes on the wires and our eyes on the leads and not lose our place. So the tone is helpful to let us know. The tone is helpful so that we don't have to take our eyes off of what we're trying to focus on. And then if we hit our selection switch, we'll go to that diode setting. I'll show you how to measure a diode. This is just a standard out of the box typical diode, nothing fancy like a Zener diode or anything. We're always going to measure our diodes in both directions. And something we want to pay attention to, let's hold that. Okay. We just took a measurement in one direction of our diode and we have this number. What does it mean? Well, we're seeing here is 0.532 volts, or think of it as 532 millivolts. And the value that's being displayed here is the amount of voltage drop across the diode. Voltage drop is its own subject that we could go into. It's very long. You just need to know that it's the voltage drop across the diode, and we want to see between 500 and 800 millivolts of voltage drop across our diode in one direction to indicate a healthy diode. And then we'll test our diode in the other direction, and we should see an OL. What does that OL mean? Well, that means open loop or out of limits, basically indicating that there's no electrical backflow in our one-way check valve that is known as a diode. And so that means it tests good. Something I always like to double check to see is if it can light up a white LED for us. And it can't. A little bit of a bummer, not a big deal, nothing critical. Let's move on to the resistors. We're gonna do more of trying to dial in the proper setting for what you're looking at and more context to this OL. So we're in the resistive setting value. What does all this mean? When we see a capital M like this on a meter, that's gonna be, think of millions. It stands for mega, and then this K is for kilo. In that mindset of up to, this setting will read up to 2 million ohms. This setting will read up to 200,000 ohms, 20,000 ohms, 2,000 ohms, okay? I always like to start biggest and work my way smallest, and we'll do some example readings here. So I have these resistors. I don't know how much resistance they are. We'll just start measuring and we'll go through the wheel. Okay, so I have a resistor, I have a value. What does this mean? Well, we're on the really big setting and we're seeing a 1.039, and then there's the M and the ohm. So this is saying that this is in mega or millions. So the way that I would read this value is 1,039,000 ohms. Okay, we'll go through another example. Haven't changed the setting at all, but now we're seeing 0.009 and we still have the million ohm setting. What would that be? Well, that would be 9,000. It's the way that we would read that, but I would like more detail, more resolution in my measurement. So now I can start cycling down the wheel. I can move it to this 200K. Okay, so we have a K here, K 1,000. We can think of 3 zeros or 3 placeholders for our decimal. So we can move our decimal place over from here, 1, 2, 3. So that's reading 9,800 ohms of resistance. And then the next setting down is 20K or 20,000. And 20,000 is still a lot more than the 9,800 that we have here. So I know that I can move on down to the next setting. And now I can read it to the hundredths place. And this is letting me know, okay, this value is 9,880 ohms. So now I've got a lot better resolution in my measurement. Before, when it was just that 0.009, I was like, cool, it's 9,000. Well, there was still 880 ohms hiding in there that I couldn't see before until I dialed into the proper setting. Now, we have a 2K, 2,000 ohms. Now, 2,000 is less than this 9,000 ohms, right? I know this 2K can only measure up to 2,000 ohms. So if I go here, I'll have an OL, and it means it's out of limits. So it's important to remember that when we're taking measurements and we see an OL, doesn't mean that there's not voltage, doesn't mean that there's not current or resistance. It could simply mean that you're on the wrong setting on your meter. So that's why I always like to start really big, because let's say this one's a really tiny amount of resistance. See how it doesn't say OL? It still has a bunch of zeros. That's telling me there's some amount of resistance that the meter's able to read. It just can't see it well enough. It's too blurred out in the background. It's too fuzzy, but it knows something is there. And as we dial it in, we'll start to get a value until finally we arrive at 0.099 k ohm. What does that mean? That means 99 ohms of resistance. We're gonna keep going with this. We're on to current. Now let's do something a little bit more fun. We'll kind of switch it up. We'll do some larger electrical loads here. Now when we're measuring current, we're going to be measuring it in series. And what does that mean? Well, that means that we're gonna be using the wires of the meter essentially as jumper cables to complete our circuit. But you notice that nothing's turned on yet, and that's what we're gonna use our meter to do. It's gonna do some magic. In the spirit of starting big and working our way small, when we have our amperage settings here, 10 amps is the largest, and then we have this lowercase m that stands for milli, and that's tiny. So it goes from whole to tiny, and then that funky looking U is micro, which is even smaller than milli. So we're gonna start big at our 10 amps, and it's letting us know, hey, switch your port lead right on over. So we'll go ahead and do that. Boom. Make sure it's fully engaged in there, or you'll have some really confusing readings. And we can use our test leads to complete our circuit. So I'm gonna use my test leads to apply power to this light bulb, and then look at that. I can see 2 amps of current being drawn. The electricity is flowing through my leads, through the meter, back out to the light bulb. Pretty cool. And then we have this motor here. This is where we want to start kind of paying attention to see when we start getting into smaller amounts of current that we're trying to measure. Let's put that on hold. So that motor is drawing 0.44 amps of current. Or we can think of it as 440 milliamps of current. We'll see down here, we'll want to pay attention to these fuses. For this one, we can measure up to 10 amps maximum current. For this one, for this port, we can measure up to 200 milliamps of current and still be safe by our fuse. So this motor is at 440 milliamps, which is over double the amount here. So we would still, even though it's a small amount of current, we'd still want to use this setting and this test lead. We always want to start big and then work our way small. So then we can do, I'll use those resistors. They make great little electrical loads. They're not exciting because they don't really light up or do anything, but they're great for showing measurements. We'll take another current measurement of another source. Okay, and this is showing 0.11 amps DC of current draw. Look at this. Oh, crap. Try that again. Okay, 0.12 amps of current draw. We could also think about this if we convert it to milliamps, this would be 120 milliamps of current. And we know 120 is less than the 200 milliamps that we have here. So what we can do is go to our 200 milliamp setting. It's letting us know, hey, change over your lead. And now that we're in the units of milliamps, we can take our measurement again. And now we're getting some nice big numbers and a lot more detail. We're getting 121.2 milliamps of current draw. So now our measurement, way more accurate. We've got way more detail. We know exactly what's going on there before. We know way more than what was going on before, right? Let's go ahead and keep going. We've got some other examples here. Okay, so this is saying 12 milliamps, and our next setting down is up to 20 milliamps. So that 12 is smaller than that 20, so I can go ahead and shift over. Boom, and look at that, and now I can read it to the hundreds. So I have 12.25 milliamps of current. And then we've got another one over here. Okay, this one's really small, 1.19 milliamps. But our next setting down is only up to 200 microamps of current. And this is reading 1,190 microamps or 1.19 milliamps. So that is the most detail that we're going to be able to get out of that. So that is the current settings for the meter. Next up, we have the battery settings. I want it to be known, as much as I'm into commercial electric, and I know that some people are going to ask in the comments, this 12 volt battery tester, this is not to test the 12 volt battery in your car. That's not what this is for. It's more of a marketing thing than anything, is they kind of give you this sense of like, oh, I can test all these different types of batteries. The 12 volt battery tester, it's not a sufficient load to test like a real 12 volt cell. The 9 volt and the 1.5 volt, those are fine. Those are like little, that's like a little home battery test. And the amount of load that it's gonna put on those is sufficient. Let's see, this should be positive and negative. And we can go ahead and test. Oh, and it even tells us good up there. That's nice. What about for this 9 volts here? That one's good as well. I like that they do that though. These are the only ones, because this battery setting is common on a lot of meters and none of them ever say good or bad. So that's really great that it does that. I'm really excited for that. And then the 12 volt, even if I've got something like this is a lithium ion phosphate battery. Yeah, it's good because it doesn't know that it's a lithium ion phosphate battery. The testers required for like a real 12 volt battery, like when you go to the auto store and you have them test your battery and they pull out that huge thing, that thing is a giant resistor to put a huge load on your battery to really stress test it. Your little meter like that is not going to be able to produce something like that. But it's great for 9 volt and 1.5 volt to test these little batteries that you have laying around your house. And then lastly, we're going to do the volts DC setting. We'll use this battery again. Some of you might be wondering, Luke, what's the difference between the volts DC and the battery test? And that's going to be the internal impedance of the meter. For those of you that are just wondering or curious about it, basically it means the amount of resistance internal to the meter. So for just my normal volts DC setting, because we know all about reading resistive values, I'm getting 10 million ohms. Okay, but when I have it on a battery setting, it's gonna drop down dramatically. Yeah, 450 ohms. So if you look into Ohm's law, we can see as resistance goes down, current goes up, right? So that's the way it puts a load on the battery to test it. In case you were wondering, the more you know. Now we have our volts DC, and this will be the last final example of starting our microscope up here and then working it down into here and why it's important. This battery is fluctuating between 12 and 13 volts DC. Now, if you know anything about 12 volt batteries, the difference between 1 volt can be a lot, right? And so I'd like to know if this battery was at 12 volts, that's a lot different than it's at 13. So I'm at my 600 volt setting, DC setting here, but as I click down, now I'm getting more clarity, right? So now I can read it to the tenths, and then if I click down, because I know it's under 20, okay, 13.29 is much different than 12, and that's why I want that accuracy. But I know 13.29 is much greater than 2, so if I do select the 2, it should show what? An OL. And there it does. And then that's gonna be for up to 200 millivolts, which is very, very tiny. If you are still learning electrical testing, if you found this video helpful, go check out, I've got a playlist all about multimeters. If you don't have this exact one, or if you're looking at getting a different multimeter, I've got like over 30 videos explaining how to use all these different meters. I've got a bunch of different shorts explaining different electrical concepts and all of that good stuff. So thank you so much for joining me on the show, and I'll catch you on the next one.